In this video today, we will do part one of our Systems of Equations unit review. Now, if you remember, at the end of every class, Mr. Green would offer us a key idea from class. And I collected those ideas, and it turns out there was 8 key ideas. And this is going from most recent to oldest. We talked about how to see if 2 lines are parallel without a graph, how to get the solutions without a graph. We actually did that a couple times. We talked about how to find where 2 lines cross, but we realized that sometimes they're parallel lines and they never cross, so there's no solution. We talked about how to find a point on a graph. We talked about the point where 2 lines meet is the solution to the system. And we spent a couple days talking about estimating at the very beginning of the unit, and how estimating can actually give you a sense of the answer before you actually do the work for it. Now, what I did is I boiled those down to 5 key ideas from this unit, and we're going to focus on those 5 key ideas right now. And the first of those 5 is that estimating helps you find out something about the answer before you start the problem. Now, if you remember, we started with that shot put problem, and we spent some time noticing things about the problem, wondering, asking questions. And that was really important, right? Because that helped us start to think and get our mind wrapped around the problem before we started trying to do calculations. When we had to figure out how long the green and the black stick was, again, we used estimation. We said, well, if the total is 76, or if the total is 15, maybe the numbers are this. Once we started jumping into the problem, then we used a variable, right? We said instead of a green stick, we just used G, or instead of writing the word black stick, we just wrote B. So noticing and wondering and variables were all helpful to us as we were getting started in this unit. The next thing that we learned, the key idea that we learned, was that the point where 2 lines meet is the solution to a system. So if you have a system of equations, which is 2 different variables, right, 2 different things you're looking for, if you want to find the solution, if you can somehow graph those 2 relationships and find that point of intersection, that's your answer. So that was the second key idea, that if you can graph 2 different relationships and find where they intersect, you have an answer or a solution. The third key idea was that parallel lines never cross. So there's actually a situation where there's actually no solution whatsoever. And we saw that sometimes when you had those parallel lines. And obviously a key vocabulary word there is slope, right? If the slopes are the same, if the speeds are the same, those lines will actually never cross. And therefore, there's no solution. The fourth key idea is that you can actually get the solution to a system without a graph. So even though we spent a lot of time talking about a graph, we use this thing called substitution. And Mr. Thomas and Mr. Lipsey kind of started us down this path by saying, wait a minute, if you take these 2 equations and you set them equal to each other, you're actually substituting them into each other. You can actually solve that without ever graphing it. So that was the fourth key idea, that you actually don't even need to graph these systems in order to solve them. And the last key idea is that in a similar way, you can actually tell if 2 lines are parallel without ever graphing them. And we learned that if you use that Lipsey-Thomas method and you start solving it, and all the variables cancel out, then that's a strange situation, right? When the variables cancel out, that's an indicator that you had the same slope, meaning that the lines are parallel and there's no answer, right? You can't solve for X, there's no solution. So those are the 5 key ideas. That estimating is an important step to do before you start a problem. Try to notice and wonder about the problem. Don't just say, I don't know how to do it, right? Notice and wonder. Second big point is that a system is where there's 2 things happening. And if you can graph those 2 things, where they cross is the solution. The third, again, idea is that if you have parallel lines, there is no solution. The fourth key idea is that you can do this work without graphing it. And that comes in really handy sometimes, even though it is a lot of work. And the last is that if you see enough patterns, you can actually find out if 2 lines are parallel without ever graphing. So in the course of this unit, we came across 2 types of problems, and we're only going to focus on one today. The one we're going to focus on is problems that are in slope-intercept form, where we also came across standard form. We'll look at that on Friday. So when problems are in slope-intercept form, the best bet to solve it is either by graphing it, which hopefully we're pretty good at. We spent a lot of time this year, or using this substitution, the Lipsey-Thomas method. If you ever have a word problem and you're looking to decide is this slope-intercept form or standard form, if you're reading a word problem and there's talk of slope or rate or speed or starting point or initial value, chances are you're talking about slope-intercept form. And that's what we're going to be looking at today. See if we can find the rate or speed or slope, starting point or initial value, write an equation, and then decide whether we want to use substitution or graphing at that point to solve that. So let's review this, see if we can solve this system I just gave you by graphing. First, you need the slope and the y-intercept of the first equation. Do you know what they are? All right, the y-intercept of the first equation is -5, because that's the b value, the constant, and the slope is +3/1. That's the coefficient of x, the number in front of x. So I want to graph that line, so I make my y and x axis. I start at -5, and I go up 3/1, up 3/1, up 3/1. I draw my line to show that that line continues forever. Then I go to my next equation, which is -1x plus 3. What is the slope and y-intercept there? The y-intercept is +3 because that's the constant, and the slope is -1 because that's the coefficient of x. So that means the slope is -1/1. So I start at +3, and I go down 1/1, down 1/1, continue my line, and see where they cross. And it looks like they cross at 2, 1. So there's my solution to that system. Now there is another way to do that by substitution, or the Lipsey-Thomas method. In that case, I would set those two equations equal to each other, and then I would start solving for x. I would add 1x to both sides, get 4x minus 5 equals 3. I would add 5 to both sides and get 4x equals 8, and then solve for x. And then once I have that x value, I can plug that back into one of the equations and get my y value. And there's my answer, 2, 1, which is the same thing I got here. You can use substitution or graphing, and depending on the situation, you would want to use one or the other. So it's important to know how to do both.